By the end of this video, you will have a character controller that can not only move but also jump using state machine. If you do not know what state machine is, watch the part 1 of the series. Now let's start by diving into a player. Make a new node called walk and attach a script to it. The script will hold our walking state code. However, before writing our code, we need to do some prerequisites. One is to add the name of our walking animation, similar to what we did for our idle animation. Second, add the variables to our corresponding state. This will help us when we will transition between states. Make them exportable so we can edit them in the editor. And finally, add the variable for our movement input key. We will use this to move left and right, map to A and D of the keyboard respectively. We will then have our idle state transition to walk state whenever any movement key is pressed. To test our changes still here, we can add a print log to our walk state's enter function, run the game, and see that the walk state has been entered. Great, but now as you can see, we have yet to add any animations to our walk state. So let's do that. With our animation now set, let's try to actually move our character. For that, we make a variable for our walking speed and start writing the code for our walking physics. Speaking of physics, since we will be dealing with gravity, let us change our player state's physics process function to apply the gravity to our player. This way, we can simply inherit this part for all of our states instead of writing it separately for each of them. Inherit this function to our idle and walk state, and we have gravity. Now, let's write the script to facilitate player's movement. Our doMove function will move the player with move speed along a particular direction. To get this direction, we'll make a separate function called getMoveDir and make a new input mapping for our left and right direction. Similarly to our movement key, add these action names as variables to our player state and use the getAccess method in our input class to get our corresponding left and right direction vectors. Test it out. Great, everything works. We now add in the transition to our idle state once we have stopped moving. With this, our basic walking code is done. Now, let's see how we can make our character flip its sprite to face the moving direction. For this, in our player state class, we will have a sprite flip boolean. This will hold the check to see if our sprite is flipped or not. Next, we will make a function that will determine when and how to flip the sprite. Speaking of when, we will see if our sprite can be flipped when we have pressed the movement key or when we have changed our direction. We will also need to pass along this sprite flipped variable across our states. Since we will be primarily flipping our sprite when we have pressed our left or right key, we will be working very closely to our current input in our determined function, which is primarily the left and right one. So, of course, we will need a variable that will store our action keys to these particular input mappings. Looking into the documentation, we can see that action get events is exactly what we need. An array of input events corresponding the particular action name, which in our case will be the left key and the right key. Let us print it out for you to better understand what this function does. As you can see, we get an array of input events corresponding to our left or right keys. However, as you can also see, the value in the array is not entirely equal to the event that has occurred right now. Primarily in our array, we have A physical, whereas we have pressed the A button. Now why this happens is a topic for another video, but for now, we can just simply slice this particular string. And voila! Our values are now equal. Since our sprite is by default facing the right direction, we will flip our sprite when we are facing the left direction, which we can easily do by calling our left array's find function, and similarly so for our right array. To flip our sprite, we just change our sprite's flip edge property to be the same as our boolean variable. To use this function, we just simply call this when we have pressed our movement key in both our idle and walk state. Now, we need to pass along this sprite flip value across our states. You will notice that our player is pretty much working perfectly without this addition as well. However, this is because we have not added any other states. If we will add more states like jump, punch, kick, etc., which we will later down the line, state management gets a lot tougher due to inconsistent values across shared variables, so we will have to do this step anyway. So better to do this now only. And then again, it's pretty simple once you get the hang of it. For this, we will have to change our base state class, particularly the exit function, to take in an optional parameter called the new state, referring to the state that we will transition into, and subsequently pass along our variables. Now it is just a matter of trickling down this change down our state machine and play a state class with just one extra step for the latter, that is passing along the value of our sprite flip variable. Now we just inherit this function across our idle and walk states. With this, our player now can walk and change its sprite. Just a reminder, if you like this style of video, that is, my devlogs and how-to videos, do consider subscribing to this channel. It motivates me a lot in making videos and also the YouTube algorithm to reach a wider audience. And yeah, we are pretty much done for today. Originally, this video was about to contain the jump state as well, but I think we have already covered a lot of technical ground today. So I would rather have you try it as a homework activity. To be fair, it is pretty simple actually, and you can easily do it with all I've taught you till now. I will be making a second part of this anyway, where I will explain how to make the jump state, probably by the end of this week. So why not give it a try for yourself till then? Okay, bye bye.